Okay, just talk about the cardiac cycle this time. So when discussing the cardiac cycle, it's about what is the different stages that a heart undergoes when it's doing its contractions. What's it doing when it's taking blood in, and how is it pumping the blood out of the heart? So there's three stages, and if we even simplify it more, we've got a stage where it has to fill up with blood, and there's a stage where it has to squeeze all the blood out. So let's talk about diastole first. And diastole is when the heart relaxes. Remember, it's a muscle. And so when it relaxes, all these muscular walls here, they all relax and the heart gets bigger. So all of the chambers are able to increase in volume. Not just the ventricles, but the atria as well. So when the volume increases, as we've talked about this before, volume increase causes pressure decrease. So if the pressure decreases, there's going to be a higher pressure outside the heart. So the blood pressure outside the heart is going to be higher than inside the heart. This is lower, and therefore blood is going to pour in. And it pours into the atria, and as the atria fill up, their pressure is going to increase as more liquid, as the blood fills it up, and it's going to force these valves to open. Remember, these valves only open down into the ventricles. They're called the atrioventricular valves. This one here is the tricuspid. This one's the bicuspid. So diastole, blood enters the atria and forces its way through the atrioventricular valves into the ventricles. And so both these parts of the heart, the upper and the lower part, are both getting filled to quite a lot. So the ventricles aren't completely full yet. So what the heart has next as a way to make it even more efficient with the volume of blood that gets brought into the heart and then gets pumped out is we have something called atrial systole. So atrial systole means atria contracting. So the atria contracts first. So that's this top part here. The left and the right atrial walls both contract. And when they contract, they cause the chambers, the atria, to get smaller. So they're getting squeezed, like a ketchup bottle getting squeezed. As they get squeezed, the volume's been made smaller, so the pressure increases, and this is forcing even more blood down into the ventricles. So now we've got an even greater volume of blood in the ventricles. So atrial systole has forced the atrioventricular valves to open even more, and it's caused a greater volume of blood to enter the ventricles. And then the third stage of this cycle is called ventricular systole, which is the ventricle walls contracting. So when the ventricle walls contract, just like the atrial walls, they are causing the ventricle chambers to get smaller. The volume gets lower, the pressure increases, and blood cannot go back to where it came. It doesn't get forced back into the chambers. That can't happen because those valves only open one way. So the atrioventricular valves are being slammed shut. They get slammed shut. So now the pressure is getting even greater. Where can the blood go? It has no choice but to be forced up through the pulmonary artery and the aorta through the semilunar valves. Now, the semilunar valves are found here. So they're being forced open. And the blood is now being pushed either to the lungs or to the rest of the body. And then we go back to diastole, where the heart relaxes, all the muscle walls relax, the chambers get bigger, the volume increases, so the pressure decreases. The pressure is now lower in the heart compared to the blood pressure in the blood vessels around it. So now blood pours back in. It's pouring down the pressure gradient. And blood is also, the blood that has just been pushed up here will naturally fall back down as well. The pressure in the pulmonary artery and the aorta will be greater than the heart when it relaxes. But as it starts to fall down and enter back in towards the ventricles, these semilunar valves are being slammed shut because they cannot be forced the other way. They can only move in one direction. Right, so 3 stages of the cardiac cycle. We have to link everything. When we talk about when valves open and close, we link it to the pressure differences. So the only time that the valves, if this is the, let's do that there. Right. If these valves can only open this way, downwards, then if there's a high pressure here with blood filled up in an area and there's a low pressure, blood is going to get forced down this way. It's quite easy, isn't it? Then, if the pressure changes and this becomes the high pressure and this becomes the low pressure, so this could be like, if we compare this to being the atria and the ventricles. When this area becomes high pressure, can blood go back up the other way? No, it can't, because the blood is going to cause these valves to get slammed shut. The blood is helping to close those valves on itself. It's like a door only opens one way. If too many people run at a door, then there's a good chance that door will get slammed shut as they will try and get through it. All right, so you've got to link the cardiac cycle with the pressure changes. You need to know the 3 stages of diastole, which is relaxation, where the heart fills up with blood, atrial systole, where the top half of the heart contracts, and ventricular systole, when the bottom half contracts. And then the last thing you've got to be able to do is interpret these graphs here. So I'm going to quickly show you something else first. Right, so this is an animation of a heart contracting, and I'll talk about this graph on the right in a bit. Let's just focus on what's happening here and here. So the 2 atria, you'll notice there's a moment where they both contract at the same time, and again they do it again. So the top half contracts together, and then as they're contracting, you'll see it pushes a little bit more blood in. As soon as that atrial contraction occurs, you will see the ventricular part also contracts. It's now forcing blood out through either the aorta or the pulmonary artery. And then also part, you'll see where the whole heart seems to relax. And you'll see when the heart relaxes is when blood is coming in through the vena cava and through the pulmonary vein. So these different stages happening. So that can be broken down, and we can see now if blood is pouring in through the pulmonary vein and the vena cava, this must be diastole. As it's pouring in, the pressure increases in the atria, and it's forcing the atrioventricular valves open. Blood is still moving in. As it starts to slow down, we now enter the 2nd stage of atrial systole. Watch the atria begin to contract. There we go, to force that last bit in. Let's just go back a bit. Now look, as more and more blood enters the ventricles, you can see the pressure is getting so great in here that these valves are already starting to close, these 2 atrioventricular valves. And the final bit that's going to completely cause them to close is when the ventricles contract. So now you can see the ventricular walls starting to move. These valves are now closed, and the semilunar valves have now been forced open. There we go. This is ventricular systole, forcing the blood out through the aorta and the pulmonary artery. Blood is now being sent either to the lungs or it's been sent to the rest of the body. Okay, so, and it goes round and round circles. This is what your heart's doing pretty much every second, all the time. Okay, so let's go back to interpreting this graph. So remember, the focus is on pressure changes. So let's have a look at these pressure changes. So this red line is showing the pressure in the aorta. So the aorta is the main blood vessel that's where blood has just left the left ventricle. We've also got the pressure of the ventricle, and we're looking at the pressure of the atria. So let's have a look what happens here. So sometimes the pressure in the atria is greater than the pressure in the ventricle, and we can see that because the yellow line is higher than the green line, which means there's either a greater volume of blood in the atria or the atria themselves are contracting. And then we can see the pressure starting to drop here in the atria, and that tells me now the atria is beginning to relax, and suddenly the pressure in the ventricle shoots up. It's a great pressure, and this tells us the ventricles are now contracting. So when that contraction occurs, well, we've got two sounds with our heartbeat. We've got dub 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 dub, or lub dub lub dub lub dub. That sound lub, you are hearing the atrioventricular valve closing. Why is it closing? Because the ventricular pressure is greater than the atrial pressure, because the ventricles are contracting. It's so great, the ventricular pressure is so great, it goes beyond the pressure of the aorta, the aortic pressure. It's gone above it now. That green line is above the red line. And you can see, as soon as the green line crosses the red line, the semilunar valve has opened. Why has it opened? Because the ventricular pressure is greater than the aorta pressure, and it's forcing blood now to an area of lower pressure. So you can see here the whole time the semilunar valve stays open, it's open, blood is going out into the aorta, and then finally, when it crosses over, that arrow should be over here somewhere. As soon as that green line goes below the red line, that's telling us the ventricular pressure is less than the aortic pressure, and therefore the semilunar valve gets slammed shut. Ventricular pressure is dropping, 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 which means the ventricles are relaxing, their volume's increasing, and their pressure gets so low that it drops below the aorta, the atrial pressure, which tells us now the atrioventricular valves have opened back up. All right. So there's other ones we can look at here as well. You might see it in this form. Again, we've got the yellow line here, although it's not showing it. There you go. It does actually. The ventricular pressure. We've got the aortic pressure and atrial pressure. So both of these graphs, by the way, they're only looking at the left-hand side of the heart because we're looking at aorta. If this was the right-hand side of the heart, it would say pulmonary artery pressure. But anyway, it's the same thing anyway. Hopefully you can see that all of this is linked to when do the valves open and when do they close? What's causing them to open? Well, here, the reason why the atrioventricular valve is closing is because the ventricular pressure has gone beyond the atrial pressure, and therefore the valves have been slammed shut. They cannot open the other way. It's only a one-way door, isn't it? Volume is suddenly dropping here. Why is the volume of the blood dropping? You can see there it's dropping down. Well, that's because the ventricles are contracting, they're squeezing, the space is getting smaller, the blood is being emptied out, and then it suddenly starts to go back up. That tells us the ventricles are contracting, the space is getting bigger, and blood can start entering again. Right, so 3 stages: ventricular systole, diastole, atrial systole. It doesn't really matter what order you say it in. Instead, that's the order. It always goes diastole, atrial systole, ventricular systole, and so on, not the other way around. You need to know the pressure differences and how that causes the valves to open and close, and then you need to be able to interpret a graph of the cardiac cycle.